Hello there guys, welcome back to another epic and extra real maths video. In this video, we're looking at a very cool topic from trigonometry. This is called the t-formulae, or sometimes known as the tangent half angle formulae. So basically, the idea of this is we're going to derive ways to write sine, cos and tan all in terms of just tan. So what this is going to let you do in a sentence is rewrite trig equations as algebraic equations, because we're just going to write all trig functions in terms of the letter t, where t is going to represent tan of like half of theta. I will show you exactly what I mean obviously in this video, but if you want to know what are we doing, why are we doing it, we're turning trig equations into algebraic equations because sometimes, not always, sometimes they can be easier to solve that way. So let's go straight in. I will show you exactly what I mean. And I've written 4 formulas here that we're going to need just now. So the double angle formulae for sine, cos and tan, and also 1 plus tan squared equals sec squared. We're going to need that one too. Okay, so this is what I mean. So first of all, I'm going to define lowercase t to be equal to tan of theta over 2, okay? And what I want to do is write down what is tan of theta, what is sine of theta, and what is cos of theta, all in terms of t. That's the idea. And then if I see a trig equation, and we'll do videos on this in the future, there'll be a little playlist for this. When we do a trig equation, if we see a sine theta, I'm just going to be like, oh, I'm just going to turn it into this function of t. If I see a cos theta, oh, I'm just going to turn it into that. And then boom, algebraic equation, everything's in terms of t. We solve it, we do a little bit of trig at the end, and we're good. So this is the premise. We're going to say that lowercase t is defined to be tan of theta over 2. Okay, how can we find everything else? Well, the most obvious thing to do first would be to find what is tan of theta. And of course for that, we can directly use the double angle formula for tan, okay? So if we imagine that capital A is theta over 2, then I can see that tan of theta would be 2 tan theta over 2 divided by 1 minus tan squared of theta, okay? So does it make sense, guys, for me to say, first of all, that tan of theta would be, just by using the double angle formula, 2 times tan theta over 2 divided by 1 minus tan squared of theta over 2. This is a direct application of the double angle formula. I've just halved the angle, right? I've just said A is theta over 2. Okay, cool. And this is the idea. We're just gonna, because we said that t is tan theta over 2, I'm gonna write this as 2t over 1 minus t squared. Okay, so tan of theta is 2t over 1 minus t squared, where t is tan of theta over 2. That's the most obvious one, right? That's just like, okay, fine, double angle formulae. Right, now let's do sine. What is sine theta? Well, let's write sine theta as 2 cos theta over 2 sine theta over 2. And apologies, I've just realized I've written 2 sine A then cos A, but here I've written cos and then sine, but obviously it doesn't matter. This is just the double angle formula again. I've just written these terms the other way around. That's fine though. Okay, now we don't know what cos or sine of theta over 2 actually are. Is there a way maybe to write this function in terms of tan? Well, yes there is. So what can we do? Well, why don't we write cos, or why don't we do this, okay? Just stay with me for a moment. I'm going to write this as 2 cos squared theta over 2 times tan of theta over 2. And this is because tan is sine over cos. So I would have sine over cos, and then it's timesing by cos squared, and one of the coses would cancel out. So we would get that. This is the same, okay? It's just tan is sine over cos. So we have that. Now, why have I done that? Well, cos squared is the same as 1 over sec squared. So I'm going to write that. And tan theta over 2 is just t. So I'm just going to replace that with t. Now I just need to know what sec squared is in terms of t. But guys, that's really easy because we know that 1 plus tan squared of theta over 2 would be sec squared of theta over 2. So this is 2 over, well, sec squared is 1 plus tan squared. So 1 plus tan squared of theta over 2. And then there's still that t there as well. I'm going to put the t on the numerator. Okay, and again, t is tan theta over 2. So I can write this as 2t over 1 plus t squared. Okay, so it looks very similar to tan theta, but it's just there's a plus instead of a minus there. So what I'm saying by this is that sine theta is the same as 2 tan theta over 2 divided by 1 plus tan squared theta over 2. So now we can express tan and sine in terms of tan. That's quite good. Okay, last one, cos theta. Okay, well, cos theta, using the double angle formula for that, it's cos squared theta over 2 minus sine squared theta over 2. Okay, now guys, we know that sine theta over 2, oh, actually, let's do this. Let's do this. Let's factor out, okay, let's factor out a cos squared. I know that some of this seems to be like not too obvious. You kind of have to have seen it. But if I factor a cos squared out, then I can write cos squared times 1 minus, and then because, again, tan is sine over cos, so tan squared is sine squared over cos squared. So this would have to be sine squared over cos squared, but I can write it as tan squared theta over 2. So I'm just, again, the objective is to write everything in terms of tan theta over 2. Now we already know that cos squared theta over 2 is 1 over sec squared theta over 2. But we already said that sec squared was 1 plus tan squared. So hopefully I'm not going too quickly, but cos squared theta over 2, I'm going to write that as 1 over 1 plus t squared, okay? Because just to be clear how I've done that, cos squared is 1 over sec squared, so it's also 1 over 1 plus tan squared, because sec squared is 1 plus tan squared, okay? And then we have a 1 minus, and then obviously tan squared of theta over 2 is just t squared. Okay, and then maybe let me just go up here slightly, just so I don't destroy my back. Cos theta would then be 1 minus t squared over 1 plus t squared, like that. So now we have written all 3 of the main trig functions in terms of tan. That's pretty good. So give me a second, let me just clear the whiteboard, write down what we've just done nice and neatly, and I'll explain a little bit more. Okay, so I've added onto our little column here of formulas, sine, cos, and tan can all be written in terms of t. So we've already derived all of these, and we've just said that t is, again, tan of theta over 2. So you can see how powerful this is. What it means is if you ever have to prove a trig identity or solve a trig equation, you now have this in your tool belt. You can turn all of the trig functions into functions of the letter t, solve it, rearrange it, do whatever you got to do, and then find what theta is like that, okay? So what I'm going to do now is I'm going to show you an example question on how to use this, and in the future there'll be more videos too. This is really helpful for things like integration. You can do integrals using this substitution. It's really good, but I just want to show you a very simple example of how to use this, okay? So maybe we want to solve the equation 2 sine theta minus cos theta equals 2. Okay, now I'm not saying this is the only way to do this. There are other ways to solve this. But it's actually not that easy of a question. You'd probably have to use the harmonic addition theorem, so use the R and the alpha if you know what I'm talking about. If you don't know what I'm talking about, don't worry. But it's not that easy. You can't really divide everything by cos, which is a normal, to get tan. You can't do it because there's a 2 there. So it's actually not a very easy question, but we know that t is tan of theta over 2, so I can just rewrite this as 2 times, well, sine of theta is 2t over 1 plus t squared, and cos of theta is 1 minus t squared over 1 plus t squared. So do you see that I had a trig equation, but now I have an algebraic equation? And don't you think that's kind of sick, right? It's an algebraic equation because it's just t's. And so now I can just rearrange, maybe I'll just times everything by 1 plus t squared and then simplify. Okay, I've times both sides by 1 plus t squared here just to get rid of the fractions. Okay, and now it's going to be a quadratic. So I'm going to have 4t minus 1 plus t squared equals 2 plus 2t squared. What can I do? I can take t squared away from both sides. I'll do it this way, guys, so stay with me because I'm going to, so t squared from both sides. Let's move the 4t to that side as well, so minus 4t. And then what is there? There's a plus 1, so plus 3 would go there, equals 0. So I've kind of, the left and right are the other way around now. I've moved everything to the right-hand side, but I've written on the left. It's a quadratic. You can use a quadratic formula. You can use factorization. You can do whatever you want. Let's factorize this. We have t, two numbers that times to make 3 and add to make 4, minus 3t minus 1. Oh yeah, that's going to work. Lovely, lovely, lovely. Okay, so we can see that t is either 3 or t is 1. So t is 3 or t is 1. Remember, t is tan of theta over 2. So we would have that tan of theta over 2 is 3, or tan of theta over 2 is 1. And then, guys, we would just do this the normal way. And the really good thing about this is that some students have problems working out what solutions they actually have once they get to this step. But tan is the easiest one. It's easier than sine and cos. Because with sine and cos, sometimes you've got to like draw stuff, and tan is really easy. You just add or take away 180 degrees or pi radians to get more answers. The only difficulty is we have theta over 2's, but it's not that bad. And I didn't say what the interval was, the range for this question, but you know, it doesn't really matter. Maybe it's just between 0 and let's say 2 pi. Let's say that we're in radians, why not? And let's say this was the interval, then what would we do? Well, let's come down here. This one here, we would have theta over 2 is equal to inverse tan of 3. And this one here, we would have theta over 2 is equal to inverse tan of 1. By the way, inverse tan of 1 is pi over 4. And then we would just double both, right? So theta, forgive my sporadicness, maybe I'll go up here, but theta would then be 2 arctan 3, which of course you could write that as a decimal if you wanted to, or theta would be 2 times pi over 4, just doubling, so pi over 2. Okay, and that would be it. There wouldn't be any extra answers to this. Those would be the only ones. But if you wanted to, you could draw a picture. The last thing that I'll say about the t-formulae that you do have to be slightly careful with, okay, is when we were deriving these, we did do a cheeky little bit of, we divided, if you remember, we rewrote, I believe there was a step, maybe this in yellow, there was a step where we rewrote, I think it was like, we wrote cos theta times sine theta, or theta over 2. I believe we wrote this as like 1 over cos theta, or like cos squared. What did we do? We wrote it as like cos squared. Yeah, it was cos squared theta over 2 times tan. There was a step when we did this. I don't know if you remember. We did this. Now, we're kind of dividing both sides, or we're dividing by cos theta and then timesing by it again. And so we do have to be careful. And just generally, the problem that I'm kind of trying to explain is that when theta is a value that makes tan be undefined, then the t-formulae will not give you an answer when there might be an answer there. Basically, when is tan of theta over 2 undefined? So when is tan of theta over 2 undefined? Well, we know that tan of pi over 2 is undefined, and then any integer multiple of pi plus that. So pi over 2, 3 pi over 2, 5 pi over 2, etc. Tan of it's undefined. So if because we're dividing by 2 already, basically if theta is an odd multiple of pi, then you won't get a value. So basically what I'm saying is, if there is a question where pi is an answer, the t-formulae will not give you that as an answer, okay? So it won't find pi plus 2k pi, okay? This will not come up as an answer, even if it is an answer, if you use this method. So whenever you finish the question, plug in, so if the interval is 0 to 2 pi, plug in pi just to see if it works. Because if pi is an answer, it won't give this to you, okay? And if you're in degrees, just to be clear, then it won't give you 180. And that's again because tan of 180 over 2, tan of 90, is undefined, okay? So, but do you see that, like, okay, fine, according to this, theta can't be 180, but there's no reason why this function, the original question, can't just, theta can be 180, there's no issue with that. So if theta is 180 degrees or pi radians, you have to check it separately, because if it is an answer, then using this method, it will not give it to you as an answer. And it's just one of the unfortunate things with tan, there's an asymptote, that's just how it works. And again, the reason this kind of happens is when we derive the one for cos, among others, this is just an example, you do end up dividing by basically 0 when theta is, you know, if you divide by cos of theta over 2, well, you know, if theta is pi, then what is cos of pi over 2? It's 0, so you're dividing. Anyways, guys, there'll be plenty more videos in the future, don't worry, but I just want to just say, I think this is a really cool topic, the tangent half angle formulae, the t-formulae, and as always, guys, thank you so much for watching. I highly appreciate it, and I'll see you in the next video. Cheers.